Hello children, welcome back to Deepika Tutorials. This is your Deepika ma'am. In the last class, we have discussed some of the basics of this chapter, that is real numbers. So in this class, I am directly going to start the exercise problem, that is exercise 1.1. So in the first question, they are given express each number as a product of its prime factors. Okay. So first question, they are given 140. So we have to express this in terms of we have to express this number as a product of its prime factors. So we already discussed what are prime numbers, children. Yes, the numbers which are divisible by 1 and the number itself are called prime numbers. So by taking the prime numbers, we have to divide this number. Okay, so we have to write like this: 2 7s are 14, so 0 as it is. Next 2 3s are 6, so we left with 1. 2 5s are 10. Next prime number we have to take is 5. You can take 5 or 7 here. So generally we take order wise. There is no compulsion that you have to take by order wise only. You can take 7 here also. So 5 7s are 35 and 7 1s are 7. So this composite number, it can be expressed as product of 2 and 2 into 5 into 7. Okay, if you want to correct whether your answer is right or wrong, you have to multiply all the primes to get. If you get the same answer, then your answer is correct. Okay, we'll check. 2 2s are 4, 4 5s are 20, 27s are 140. Yes, our answer is correct. Next question is 156. So how we can express this? Will you try, children? Along with me, you also check. So 2 7s are 14. We left with 1. 2 8s are 16. Next 2 3s are 6. Next 2 9s are 18. 2 1s are 2. See, children, here in the unit place it is of odd number. So odd number cannot be divisible by 2. Therefore we have to take 3 here. 3 1s are 3, 3 3s are 9. And we know that 13 is a prime number. It cannot be divisible by any number. So 13 1s are 13. So factors of 156 are 2 into 2 into 3 into 13. These are the prime factors of 156. Next we see 3825. Okay, children, will you try? Yes, try along with me. So 3825. See, children, we can't take 2 here. Okay, now divisibility rules are also important, necessary to understand this concept. Okay, so here odd number is there. Okay, if it is there like this means we can't take 2. And also, do you know the know the divisibility rules of 3? Yes, we check random by trial and error method. We have to check this number. So 3 1s are 3. Okay, so 3 2s are 6. 3 we left with 2. Okay, 3 7s are 21 and we left with 1. 3 5s are 15. Next 3 2s are 6. Sorry, 3 4s are 12. 3 2s are 6. 1 left with, so 3 5s are 15. Next again, can we check with the 5? 3 1s are 3. No, it cannot be divisible by 3. Next we have to take 5. See, if you take 3 means 3 1s are 3, 3 4s are 12. We left with 5. 5 cannot be divisible by 3. Therefore we have to take next number as 5. So 5 4 will not come in 5 table. Therefore we have to take both the numbers. So 5 8s are 40 and we left with 2. 5 5s are 25. Next 5 1s are 5. We left with 3. 5 7s are 35. And last 17 1s are 17. The prime factors of 3825 are 3 into 3 into 5 into 5 into 17. Okay, if you want you can cross verify whether we have done correct it or not. So 3 3s are 9, 9 5s are 45, 45 into 5. So 5 5s are 25, 5 4s are 20 into 225. Again we have to multiply with it 17. So 7 5s are 35, 7 2s are 14, 14 plus 3 17. So 7 2s are 14, 15. So 2 2 5. So 5 12, 8 and 3. So we got the same answer as that of question. Okay, we have done it correct. So every time you used to check. So next question they are given. $5,005. Okay, so do it. 5 ones are 5, 0 as it is, 0 as it is, 5 ones are 5. Okay, check. Next, which number it will go? You have to by trial and error method you have to see. So here it is a odd number. We check with 3. So 3 3s are 9. We left with 1. So next 3 3s are 9. We left with 1. And 11 will not be divisible by 11. Yes or no? So it is not 3. We can't take 3. Next you take 11. See, I know here I will take 11 directly. If you don't know means don't worry. You need to check one by one. The all prime numbers you need to check. Okay. So if I take next number as 5, so 5 2s are 10, 0 0 and 1 cannot be divisible by 5. Okay, so next prime 7 I will take. We check with the 7. So 7 1s are 7. We left with 3. So 7 4s are 28. We left with 2. So 7 3s are 21. Next 11 1s are 11. Okay, we left with 3. So 11 3s are 33. And last number is 11 ones. 13 ones are 13. So what are the prime factor of 5005? 5 into 7 into 11 into 13. Okay, so next number is 7429. So see children, in some of the problems we may not get direct simple number as 2 3. Okay, in that cases we have to patiently check the numbers, prime numbers from smaller to bigger number. Okay, 7429. See children, so first see here is odd number. We do whenever there is a odd number in the unit place, there is no necessity to check with the 2. It is understood. Okay, once we check with the number 3. If I take number 3, 3 2s are 6. We left with 1. So 3 4s are 12. We left with 2. So 3 7s are 21. And last we remain with 19. 19 cannot be completely divisible by 3. Therefore, we can't take 3. Next number if you take 5. So we know that if any number is divisible by 5, it should be in the unit place. It should be having 0 or 5. But here we are having 9. So it also not possible. If you take 7, so 7 ones are 7. Okay, 0 if you take 7 sevens are 49. It will not come. 7 6 are 35. It is also not possible. 35 left means 79. 35 means 7 we left with. So 79 is also not completely divisible by 7. Therefore, next number if you take 11 also it will not be complete. So next number it will divisible is 17. So 17 ones are 17, 17 twos are 34, 17 threes are 51, 17 fours are, yes, tell me. So 17 fours are 68. So we left with 62. So 62, 17 threes are 51. So we left with 11. So 17 sevens are 190. Next number. See, next any small with a single digit, any single digit will not be divisible by any single digit. So next we try with the number 19. So 19 ones are 19, 19 twos are 36, 19 threes are 57. It will not be divisible by 57. Therefore 57 is bigger than this number. Okay, we take 19 twos are 38. Okay, if we take 38 means how much it will be left with? 38 means here 2, here 3, so 57. 19 threes are 57, and lastly 23 is on the 23. So the number 7429 can be expressed as 17 into 19 into 23. Okay children, getting? So this is first one. So in the next main, what they are giving, find the LCM and HCF of the following pairs of integers and verify LCM into HCF is equal to product of two numbers. This is one of the most important concept of your real numbers chapters, children. See what they are telling. There is one important formula for you people. You have to note it. So whenever you take two numbers, and if you do the HCF and LCM of those two numbers, it will be equal to the product of those two numbers. Okay, so what it explaining by the one example, first an example I will show you. Okay, 26 and 91 they are giving. Okay, so first we do by doing the prime factorization. Let us find out first, okay, prime factors of 26 and 31. Let's start. So 2 ones are 2, 2 threes are 6. Next 13 ones are 13. So what are the prime factors of 26? 2 into 13. Next 91. So we can't take 3 here because 3 threes are 9. We left with 1. It is not possible. So can you tell me which number we have to take? Yes, 7 we can take. 7 ones are 7. We left with 2. 7 threes are 21. Yes. Next 13 ones are 13. So what are the prime factors of 91? So 91 is equal to 7 into 13. Okay, I am telling the simplest method. You will not get confused if you understand it properly. Okay, so how to identify the HCF? Yes, I have told, no, you have to take the common pair of these two numbers. So which is common in both the numbers? Yes, 13. Can we take 2 as in along with the 13? No, because 2 is a prime factor of 26 but not of 91. In the same way, you can't take 7 because 7 is a prime factor of 91. It is not there in the prime factors of 2. Okay, whichever is common, no, that pair you have to encircle and you have to take once. Okay, HCF of this number is 13. Next, we have to find the LCM. How to find the LCM? What are the different numbers, different prime factors you are having? You have to write them once and you have to take the highest power of it. See children, highest power, here all the numbers having power 1 only. Okay, now if it is not there on the power means it is understood that there will be always 1. Okay, now so all the numbers having power 1 only. Okay, so the LCM of these two numbers is 2 into 7 into 13. So if you further multiply means 7 twos are 14, 14 into 13, you multiply and get the answer. 4 threes are 12, 3 ones are 3, 4 plus 1 fours are 4, 1 ones are 1 fours are 4, 1 ones are 1. So answer is 182. So how much LCM we got? 182. And what the HCF we got? 113. So what this formula tell us means, if you take any two numbers, it will be, this formula is applicable for only the two numbers, not for any three numbers. If they are given, they are telling us to find the two numbers LCM and HCF, then it is only applicable for two numbers. Okay, see here, first we have to use this, take this equation 1 or form, take it as form 1. Okay, we have to multiply the HCF and LCM. Okay, so HCF into LCM, I will take the LHS. Okay, LHS is equal to HCF into LCM. What is the value of HCF? Yes, 13. What is the value of LCM? 18. So you multiply the both. So 13, 182 into 13. Okay, 2 3s are 6, 3 8s are 24, 3 1s are 3 5, plus 1 2s are 2, 82. So 6 12 2. So we got it is 2266. In the same way, if you do the RHS is equal to product of those numbers. Product of those two numbers means whichever given in the question, we have to take those two numbers. Okay, 26 and 91. We have to do the multiplication. 6 ones are 6, 9 6 are 54, plus 2 ones are 2, 2 9s are 18. 6 6 13, sorry 12 2. Yes, RHS also we got same answer. LHS is equal to RHS. Okay, what they are given, children? See, find the LCM and HCF. First we need to find the HCF and LCM. After that, this we have to verify this formula obeys or not. Okay, check, children. Here LHS is equal to RHS, hence verified. Okay, now for any two numbers you say, you will get always LHS is equal to RHS. Okay, so next question, 510 and 92. Okay, so first we'll do the prime factor also, factorization of 510. So 5 if you take means 5 ones are 5. See, children, whenever there is a smaller number, so we should not directly supposed to take 2. 5 ones are 5, 5 twos are, if you take 5 twos are 10 directly means, then if you multiply these two numbers, 12 5s are 60 we get. Okay, then whether it is correct? No, wrong. Whenever we taking the two numbers directly, we have to write 0 here. Okay, so after writing the 0, next we have to take the two numbers. So 5 twos are 10. Next 5 ones are 5. See, again it cannot be divisible by 5, because here the unit place is, in the unit place we are having 2. Okay, so let me take 5 2. So 2 5s are 10, 2 1s are 2. Next 17 3s are 51, 3 1s are 3. Okay, so 5 10 is equal to 2 into 3 into 5 into 17. It will be easy when we write in the order wise from smaller to big. Next number is 92. So how we can write, in which tables it will? So in the last place, unit place, we are having 2, so therefore it is divisible by 2. So 2 4s are 18, 2 6 are 12. Next 2 2s are 4, 2 3s are 16. Next 23 is a prime number, so 23 ones are 23. So 92 can be expressed as 2 into 2 into 23. Okay, here 2 is repeated, so I will take it as 2 square into 23. Okay, so to find the HCF, what I have told, we have to check the once you check, yes, 2 is common in the both the numbers. Next, any number common, children? No, therefore we have to take 2 as a HCF. For LCM, what I have told, yes, we have to take all the primes once. So what all the prime numbers we are having, don't bother about the powers. Okay, first you write all the numbers which are there in the primes factorization. 2 into 3 into 5 into 17 into 23. Okay, and you multiply those numbers. Sorry, you have to next you have to identify the in these two which number having the highest power. Okay, So here you see it is having 2 to the power of 1, but it is having 2 to the power of 2. So we have to take highest power of 2. And if you take remaining all numbers is not repeating, no, they are having only ones as their power. Therefore we have to multiply these all numbers to get the answer. So 2 square is 4. 4 3s are 12. 12 5s are 60. So 60 into 17 into 23 we have to do. So let me check. 17 23. So 7 3s are 21. 7 2s are 14. 14 plus 2 16. Next 23. So 1 9 3. Next 391 into 60. So 093. Sorry, 000, no, 0 1 is next plus 6 1s are 6, 6 9s are 54, 6 3s are 18, 18 plus 5 means 23. So 2 3 4 6 0. So we got the product of, we got the LCM as 2 3 4 6 0. Okay, yes, we are having the formula HCF into LCM is equal to product of those two numbers. We take the numbers as A and B here simply. Okay, so we got HCF as 2, LCM as 2 3 4 6 0. Okay, so we are having the numbers 510 into B number as 92. Okay, so now we check if 23 for 23,460 you multiply with 2, what the number we will get? Okay, 2 zeros are 0, 2 6 are 12, 2 4s are 8 plus 1 9, 2 3s are 6, 2 2s are 4. So we got answer as 46920. Okay, again we have to multiply. We have to check whether if you multiply these two numbers whether we will get same number or not. We will verify. Okay, 2 zeros are 0, 2 1s are 2, 5 2 5s are 10 plus 9 zeros are 0, 9 1s are 9, 9 5s are 45. 0 2 9 6 5. Yes, good. We got the same answer here also. Getting, children? You have to verify if you multiply the HCF and LCM of those two numbers, okay, and if you multiply the given two numbers, we should get the both answer same. Understood, children? Yes. So next question is 336 and 54. Okay, so prime factors of 336. 3 1s are 3, 3 1s are 3, 3 2s are 6. Okay, so next 2 5s are 10, 2 6 are 12. Next 2 2s are 4, 2 8s are 16. 2 1s are 2, 2 4s are 8, 2 7s are 14, and lastly 7 1s are 7. Okay, so how we can write the prime factors of 336? Yes, you can take 2 here also, no problem. 2 into 2 into 2 into 2. So how many times it is repeated? 4 times. 3 into 7. So how we can write it is as 2 to the power of 4 into 3 into 7. Okay, again we do the prime factor of 54. 2 2s are 4, 2 7s are 14. Next, it will not be divisible by 2, so you take 3. 3 9s are 27, 3 3s are 9, 3 1s are 3. Okay, children, so what are the prime factors of 54? 2 into 3 into 3 into 3. How many times 3 is repeated? Yes, very good, 3 times. 3 to the power of 3. Okay, now our work is to find the HCF. So how will you find? Yes, common numbers. So what are the common pairs we have to identify? This is one common pair, again 2 is not there to pair, and one more number 3 is there. Okay, so therefore what is the HCF? 2 into 3. Yes. So 2 3s are 6. Next, how we to find LCM? Yes, we have to write down the numbers which are all there in the prime factors. Don't bother about the powers first. You just write down the numbers. So what are all the numbers here? We are having 2, 3 and 7. Okay. Now you see carefully. Here the power of 2 is 1 and here the power of 2 is 4. So in these two, which is the highest power we are having? Yes, 4. The highest power is 4. Therefore, we have to take the highest power of it. Next, you see children. Here we are having 3 power as 1 and we are having 3 power as 3. So which is the highest power we are having? Yes, 3. Therefore, we have to write 3. And 7 is only one number and its power is 1. Okay. Now we multiply the numbers. If you multiply the 2 4 times, what you will get? Yes, 2 2s are 4, 4 2s are 8, 8 2s are 16. Next, 3 times. 3 3s are 9, 9 3s are 27 into 7. So multiply the numbers. Okay, so 16 into 27. First two numbers we have to multiply. 7 6 are 42, 7 1s are 7, plus 3 means 11, plus 2 6 are 12, plus 2 1s are 2, 2 6 are 12, 2 1s are 2, plus 1 means 3. So 3 2 3 4. We got it as 432. Again you multiply that number with the 7. Okay. So 2 7s are 14, 7 3s are 21, 22, 7 4s are 28 and 30. We got answer as 3024. Okay. Now we have to check the condition. HCF into LCM is equal to product of those two numbers. Okay. What are the HCF we got? 6 into LCM 3024, which is equal to A is 336 here and B is 54. Okay, we have to multiply and verify the condition. So I will take 3024 into 6. 6 4s are 24, 6 2s are 12, plus 2 means 14, 6 zeros are 0, but carry we are having 1, 3 6 are 18. Okay, we got 18144. Okay, and 336 into 54 if we do means which we will get, we'll see. 4 6 are 24, plus 4 3s are 12, 12 plus 2 14, 4 3s are 12, plus 1 13, plus 5 6 are 30, 5 3s are 15, 18, 5 3s are 15 and 16. So how much will we got? 4 10 11 8 1. So we got both LHS and RHS are equal. Therefore we have verified the condition. Are you getting, children? All the problems are very easy. Just we need to do the answers very patiently. Okay. Next children, third main, what they are given. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay. So first question they are given 12, 15 and 24. See children, in the previous question we have done the LCM and HCF of only 2 numbers. Here they are giving 3 numbers. Same way what we are done in this question, we have to do, but by taking LCF and LCM we need to be careful. Okay, we have to take the HCF of 3 numbers, LCM of 3 numbers. Let me do. You try along with me also. You have to take pen, pencil. You should not supposed to listen it simply. Okay. So 2 6 are 12, 2 3s are 6, 3 1s are 3. Next 15. 5. You can take in 3 5s are 15, 5 1s are 5. 21. 7 3 7s are 7 21, 7 1s are 7. Okay. So what are the factors of 12? 2 into 2 into 3. What are the factors of 15? 3 into 5. What are the factors of 21? 7 into 3 or 3 into 7. Okay. So what is HCF, children? The number which is common in all the three numbers. So which number you are seeing here? Yes, that is number 3. We should not take only two numbers. Here we are doing a LCM, we are finding a HCF of these three numbers. Therefore the number should be common in the three numbers. Okay, therefore the number which is common in three numbers are 3. Therefore answer is HCF is 3. Okay, so we can write this as 2 square into 3. Okay, next LCM. So how will you find LCM? Yes, what I have told, we have to write all the prime factors which are all there in the prime factorization. We have to write it first. After that we have to write the highest power of it. See children, here only 2 is repeated, so it is having highest power of 2, and remaining, see children, you should not supposed to write 3 square. In one number it is not there. Okay na? So all the numbers it is having 1, 3 to the power of 1, 3 to the power of 1, 3 to the power of 1. Be careful. Some of the children will write it as 3 cube. It is not 3 cube. It is the HCF only. Single in each number which is the highest power we have to refer. So in this power 1, in this power 1, in this power 1. Therefore 3 and 5 and 7. Okay. So 4 into 3 into 5 into 7. 4 3s are 12. 12 5s are 60. 60 into 7 means 420 we will get. Okay. So here there is no, we should not supposed to check the condition HCF into LCM is equal to product of three numbers. Okay na? It will, that formula will applicable whenever there is only two numbers. Okay. So next question. (17, 23) and 29. Okay, so 17 means, in which number 17 will come? No, 17 ones are 17. 23 also prime number. 23 is ones are 23, and 29 ones are 29. Simple, no? So what is the HCF? It is very important, see children. See, factors of these are 1 and 17. Factors of these are 1 and 23, and factors of 29 and 1 and 1. Which are the number which is common in all the three numbers? S, 1. Therefore HCF is 1. And LCM is S. We have to write all the numbers with the highest power. There is no highest power, only 1 is the highest power here. If you multiply all these numbers, you will get the LCM. Okay, find it children. Next, third question. 8, 9 and 25. So 8, it will be divisible by 2 4s are 8, 2 2s are 4, 2 1s are 2. Okay, 9 means 3 3s are 9, 3 1s are 3, and 25, 5 5s are 25, 5 1s are 5. So prime factors of 8 are 2 into 2 into 2, that is nothing but 2 to the power of q, and powers of factors of 9 are 3 into 3, that is nothing but 3 square, and powers of 25 are 5 into 5, that is nothing but 5 square. Now we have to find the HCF and LCM. How will you find the HCF? The number which is common in all the three numbers. Yes or no? Do you find any number which is common in all the three numbers? No. See children, 2. Here the 2 is not in the factor. It is not a factor of 9 and 25. If you take 3, 3 is not a factor of 8 and 25. If you take 5, 5 is an octave factor of 8 and 9. See children, no one number is common in all these three numbers. See, if any number is not there means then the HCF of those numbers is 1. Keep it in mind that it is not 0. If no number is repeated in all the 3 numbers, means the HCF of those numbers is 1. Okay, important children, some of the students will write it as a 0. So 0 is not a correct answer. HCF is 1. Okay na? If they are not repeating, means at least 1 is common, no? For every number it will 1 is a factor of every number. Okay, so HCF is 1. And LCM we have to find. Okay, what I told children, we have to write all the prime factors at once and we have to write their highest power. So highest power is 3 here, here 2 and here 2. Okay, if you multiply these numbers you will get the answer. That is 3 square is 8, 3 square is 9 and 25. If you multiply these numbers you will get the answer. Okay, right children. Next, fourth question, what they are given, you see children. See, given that HCF of these two numbers is equal to 9. Okay na, we had to use the formula here. What formula? HCF into LCM is equal to product of two numbers. Okay na, what are those two numbers here? 306 and 657. Okay, so what is the HCF? They are given, see, HCF of those two numbers is 9. Therefore 9 we have to take here and we have to find the LCM of those two numbers. Yes or no? We are knowing now, whenever there is a product sign, if we transpose this to this is LHS, this is RHS, right? So whenever the multiplication is there in between two numbers, if we are transposing the number from LHS to RHS, that is from one side to another side, then the product multiplication will goes to the denominator. Yes, then we have the RHS has 306 into 657. Okay, so here product is there, whether you can divide 9 with this number or 9 with this number. Okay, if I divide 9 with this number, 9 sevens are 63, we left with 2, so 9 threes are 27, and if you multiply 306 and 73, we get the LCM. So 306 into 73, 6 threes are 18, 3 zeros are 0, 1, 3 threes are 9, plus 7 6 are 42, 7 zeros are 0, 4 as it is, 7 threes are 21. So 8, 3, 13, 2, 2. So answer is 2 2 3 3 8. Got it children? The LCM of those two numbers is 22,338. So this type of questions are very important children. They may be asked for 1 or 2 marks. A very important concept it is. Okay. So next, fifth question. So what they are asking, see children, check whether 6n means 6 to the power of n can end with the digit 0 for any natural number n they are asking. Okay, observe the question carefully children. What they are asking, they are given, see here n is any natural number. See, first I will tell it generally, after that we will see. Okay, so 6n, so in the place of n, if you take any natural number, whether it will be divisible in the answer in the end digit, that is in the units place, whether we will get 0 or not, they are asking. Okay, so we'll check. Okay, now see children, can I write, see children, if any number is divisible by if any number ends with digit 0, then it should be having factors 10. Okay, now suppose you see, just other example I am taking. If I take 210, if it is divisible by 10, 10 ones are 10, 10 twos are 20, 20 ones are 10 ones are 10. So if any number is having 0 in its last digit, okay, in the units place, it should be divisible by 10. Means Again, if you do the prime factor of 10 means you will get 5 and 2. What it indicates? If any number is, we are telling, if any number is ends with 0, then must and should it is having a 5 and 2 as its factors. Okay, then only we can tell that given number will ends with a 0. So here you see what are the factors of 6 and suppose if I take 6, what are the factors of 6 children? 2 into 3. Okay, if you take n to the power of 1 we get 6. If you take 6 to the power of 2, 6 into 6 36 will get. Okay, if you take 6 to the power of 3, 6 into 6 into 6, how much? 6 is the 36, 36 is the 226. If you go on doing up to n number of times, you will not get any number with ends with 0. Why? Because here we are having the factors as 2 and 3. Yes or no? But if any number ends with 0, it should have the factors 2 and 5. Both the numbers it should have. Okay, but here we are having only 2. We are not having 5 here. Therefore, the given numbers 6, that is 6n, will not be end with digit 0. Understood, children? If you want, you can write, if any number ends with digits 0, then it should be having 10 as its factors. That is, it should be divisible by 10. That is 10, further we factorize 10 means 2 into 5. It will be, it should contain 2 and 5 as its factors. Okay, but here, but factors of 6 are 2 and 3. Okay, here we observed 5 is not a factor of 6n. Therefore, 6n will not end with 0. Understood, children? If it ends with any number, if it ends with 0, then it must and should have 5 and 2 as its factors. Okay, so next question. So what they are next in the 6th question, what they are telling, explain why 7 into last 2 questions, children, 7 into 11 into 13 plus 13, and one or more number they are giving, 7 into 6 into 5 into 4 into 3 into 2 into 1 into 1 plus 5. So whether these two numbers are composite numbers or not, they are asking. Okay, we'll see. See, children, what I have told, if you want to, how many numbers are there? See, only plus or minus symbol will separate the numbers. Okay, this is one number and this is one number. So in the both the numbers 13 is common. I will take 13 as common. So what we left with 7 into 11 plus here already we have taken 13 outside. So we left with 1 here. So 13, 17, 7, 11 7s are 77 plus 1. So 37, 13, 17, 7 plus 1 means 77 plus 1 means 78. Okay. So what is composite number? It is having more than 2 factors. Yes or no? Here 2 or more than 2 factors. So see, children, 13, 17 is not a prime number. See, 13 is a prime number. 78 is not a prime number. Okay. So to tell a composite number, what it is having? It should have more than 2 factors. Yes or no? So 1 is a factor of every number. So except this, if it is only 13 means then we can say it is a prime number, but it is having more than 2 factors. Okay, 1, 13 and 17. If you reduce to 78 again means 2 3 is 6, 2 9 is 18. So 3 ones are 3, 3 threes are 19. Again we'll get 2 into 3 into 11. So it is having more than 2 factors. Then obviously we can say yes, there it is a composite number. Understood, children? What is composite number? It is having more than 2 factors. It should not be divisible with 1 and the number itself. Okay, more along with the 1 and the number itself, it is having too many factors. We can say it as, if it more than 1, if it is also having, means we can tell it is a composite number. Okay, the same way you try this one. Okay, so 7 6 are 42, 42, 5 4 are 20, 3 2 are 6. Okay, 42 into 2 6 are 120. Okay, now 42 into 12 you do, 2 2s are 4, 2 4s are 8. Next 42, so 4 10 5. Sorry, in both the numbers which is common? 5. If you take 5 common, so we are left with 7 into 6 into 4 into 3 into 1 plus 1. Okay, so if you multiply all these numbers, you will get 1008 plus 1. Okay, so 5009. So here the 1009 is a prime number, but it cannot be reducible, it cannot be factorized further, and it is also cannot be factorized further. Okay, so 1 is a common factor of all these. Along with the 1, again 2 numbers we are having as a factor. Okay, therefore it is a composite number. See, along with 1, if you got only this as a factor or this as a factor, then we can say it as a prime number. But is here we are having more than 2 factors, therefore it is a composite number. Okay, so next and last question. It is very important, children. These type of word problems are very important. Let's observe it carefully. There are a circular path around a sports field. There is a one sports field, children. See, it is in the circular path. Okay, there is a sports field. It is in the circular path, circular shape. Sonia take 18 minutes to drive one round of the field, and while Ravi takes 20 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes they will meet again at the starting point? See, children, what they are asking. First, understand the question properly. There is a circular sports field. There are 2 people, 2 friends. One is Sonia and one more is Ravi. Okay, both are running. They are starting from the same point at the same time. So to complete this circular path, Sonia will take 18 minutes while Ravi will take 12 minutes. Then children, tell me, who is running fast? Yes, that is Ravi. So what they are asking, after how many minutes they will meet at the same point, starting point again. See, children, is it possible or not? Yes, it is possible. So if he will run fast, means okay, she will running very slowly. She is running very slowly. Okay, now compared to Ravi, but they will meet at a starting point after some minutes. So what is the time? We have to find it. So for this type of questions, first we have to understand what we need to find, whether we have to find the HCF or LCM. Okay, children, see how to think the question means we see HCF, highest common factor, LCM means multiple. So when we need to find HCF means there is possible to see in these 2 numbers, if I assume smaller numbers in these 2, if suppose I take 2 minutes, whether it is possible to HCF means we know it is almost about factors. We don't get the numbers more than this. Suppose if you see 18, what are the factors of 18? 1, 2, 3, 6, 9 and 18. Okay na, we will not get the, see, factors are finite. Okay, so if you do the HCF, we will not find the number more than this. Okay, so if you get the, if you want to find the smaller answer, okay na, suppose if I just take carefully, if I want to, if suppose I will take 2 minutes as an answer, children, think whether 2 minutes is possible. They are taking 12 and 18 minutes. If suppose I think 2 minutes is possible to, in the 2 minutes it is possible to come, okay, 2 minutes will not be the answer. Therefore we should to find the HCF, we have to find the LCM. So we have to do the LCM of those two numbers, we will get the answer. So which are the two numbers? 12. So 2 6 are 12, 2 3 are 6, 3 1 are 3. If you take 18, 2 9 are 18, 3 3 are 9, 3 1 are 3. So 12 is equal to 2 into 2 into 3. 18 factors are 2 into 3 into 3. So what is common, children? So we don't need doing HCF here. Directly we do the LCM. So what is LCM? Yes, we have to write the, so it is 2 square into 3. It is 2 into 3 square. So what is the LCM? We have to take all the numbers and with the highest power. Here highest power of 2 is 2 and 3 is also 2. 2 square is 4, 3 square is 9. So answer is 36. Though after 36 minutes they will meet at the starting point. Okay, children, understood? So practice well. This is all about your exercise 1.1. In the next class we'll start the exercise 1.2. If you like the video, please do subscribe, share the video. Thank you.